Welcome to this third tutorial that focuses on working with binary shift. And we've been working with left binary shift, which allows us to multiply binary numbers. Okay, so let's have a quick recap here. Well, I have an 8-bit or a 1-byte number, 0001. That's the first part of it, 0001. And I apply a left shift of 3. That means I'm going to multiply it by 2 to the power of 3. There we go. That equals 2 times 2 times 2, which of course is 8. Well, let's test out that hypothesis, shall we? We're applying a left shift of 3, so it means we remove the leading 3 digits. We move everything along 3. That's 1, 0, 0, 0, 1. And of course we've got a gap of 3, so we just fill that in with zeros because we don't like gaps. Let's see what our resulting number is. Well, we've got 1 in the 128 column, nothing in the 64, nothing in the 32, nothing in the 16, but we've got 1 in the 8. Okay, so we add those two together. 8 and 8 is 16. Carry the 1. 2 and 1 is 3. And the 1. 136. Well, let's see what our original number is. Our original number, we have 1 in the 1 column, nothing in the 2, nothing in the 4, nothing in the 8, 1 in the 16. That's 16. Let's add those together. 6 and 1 is 7, of course, and 1 is 17. Right, we've said that the multiplication will be by 8. Okay, so let's have a look at this. 17 times 8. Oh, just undo that for a second. That's slightly better 8. Okay, you get 17 multiplied by 8. Well, 8 sevens are 56, so 6 and 5 carried. 8 ones, of course, are 8, and 5 is 13, 136. So, our original number multiplied by 8, or 2 to the power of 3, is 136. So let's have a look at this. This points to a very powerful pattern when we apply binary shift. If I have a left shift of 1, that means I'm multiplying by 2 to the power of 1, or in other words, I'm timesing it by 2. If I have a left shift of 2, that means it's 2 to the power of 2, which means it's multiplying it by 4. If I have a left shift of 3, that means it's 2 to the power of 3, which is 8. If I have a left shift of 4, it's 2 to the power of 4, which is 16. Let's just double check our numbers here. Let's start with 2 to the power of 3. Well, 2 to the power of 3 is 2 times 2 times 2. And of course we know 2 times 2 times 2 is 8. Let's check our left shift of 4, which is 2 to the power of 4. Well, that's 2 times 2 times 2 times 2. Oops, times, there we go. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can see that there's a pattern happening here. 2, 4, 8, 16. So our next left shift should actually multiply by 32. Let's check that. So left shift of 5 is 2 to the power of 5, which we are saying is times 32. Let's have a look at that. We've got 2 times 2 times 2 times 2 times 2. just fit it in. So let's have a look. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So of course, our pattern would just carry on. There's 2 to the power of 6, which of course would be 64, and a left shift of 7 would be 2 to the power of 7, which would be 828. And of course, in a byte, we know that the leftmost digit, the 128 column, is 2 to the power of 7. So thank you for viewing and listening to this third tutorial that has been dealing with binary shift to the left.